Hello, this is the last video in this chapter, and it'll be very short. And I I wanted to mention this at a point. There is a major difference between my lecture, my curriculum, and the textbooks. So in the textbooks, there are two different chapters. Usually, well, the name could be different, but main idea is they consider two different cases when sigma is known and when sigma is unknown. Uh, and in the textbooks, they use different methods, and basically they use students' t distribution, which I do not use. Like especially when sigma is unknown, they introduce students' t distribution and they suggest use this guy. By the way, student is a writing name for a statistician. I don't remember his original name, true name. But anyhow, he wrote papers, articles under the name of student. So this distribution is called student's t distribution. And instead of using student's t distribution, I unified all these methods using the central limit theorem. Remember, the central limit theorem does not require anything but larger sample size. And large sample size is actually not that large. Having, like, say, 100 observations is not much of a constraint at all these days. So it holds almost always. So then, whenever the central limit theorem holds, my theory holds, my method works. And so it's a unified method. So I believe my method is more is better and more up to date. And let me explain. Students' t distribution, the major difference between students' t distribution and normal distribution is that first, students' distribution requires a very strong assumption that the single outcome's underlying distribution must be normal. In our previous example, like presidential election example, the underlying distribution was binary, which is not normal. So students' t distribution theory does not work in that example. And the previous example, COVID-19 3-month cost, I did not mention what is the underlying distribution. The distribution of the cost may be skewed or maybe uniform or maybe bipolarized. It could be totally different, but I don't care. My method works no matter what the underlying distribution is. That's the major difference, I think. But another difference here is students' t distribution is not an approximation, but it is an exact distribution for any sample size. It works for any sample size, even if the sample size is very small, as long as the underlying distribution is normal. Still, it's very strong. So, under very strong assumptions, students' t distribution obtains a strong result. But that means it lacks wide applicability. On the other hand, what I use is normal approximation based on the central limit theorem. So mine is an approximation, not an exact analysis. So first, I do not require any shape of the shape of the distribution is not required. So binary distribution is okay. You don't need to know what is the underlying distribution as long as you know the mean and standard deviation. So it does not matter. But what I require is the sample size. Sufficiently large. Textbooks say greater than 30 or 35, but I said 100 because 100 is not that difficult to collect in most cases. These days we talk about big data which has like more than million observations. So having too small sample size is usually not a big concern anymore. But my method is an approximation, and its error diminishes only when the sample size increases. So I cannot handle the approximation error in our method. But let me show you. Still, I do respect. I have to give the credits to the student t distribution because the student t distribution uses the same form, standardization. So later, this statistic, this transformed statistic will be referred to as the excuse me, t statistic. So even though I do not use the distribution itself, but still the name remains. The name for this guy is t statistic, and everyone uses t statistic. And t distribution is very similar and converges to the standard normal distribution. So even if there is an approximation error, that's very small. And I believe in the near future, textbooks must be updated. Textbooks do not need to introduce students' t distribution at the undergraduate level. At the college level, it's pretty much useless. But maybe if you're interested in the theory, then it may entertain you as a theory, but practical usage, it has no advantage, I think. This is the last picture I show you. I don't know what is what. Like, I am drawing a standard normal distribution and t distribution, comparing standard normal and t distribution when the sample size is 30. I don't know what is what. They are so similar. So why do we use the t distribution? You may just use the standard normal distribution, and they are even more similar when the sample size is larger. So when you have large enough sample size, like 100, then literally you cannot distinguish them. Those two must be the same, but absolutely the theory based on the standard normal distribution is more widely applicable and easier to understand. And more robust. It requires milder assumptions. So that's when. So I'm telling you because many of you, some of you, hopefully, many of you read the textbooks, and you may wonder why the textbooks are saying something different from what I do. The major difference is this student's t distribution, which is an old-fashioned method, and which I don't think important anymore. And I am unifying. I give you a unified framework. Okay. This video will be posted with the homework 8, and maybe next I plan to have a homework 8 walkthrough, but today I don't have time. I think time is already up, and I bought, as I mentioned last time, I purchased a tablet like this is tablet writing on here, and I will see how it works. If it works well, then I'm going to show you how to solve the homework, or like by showing my algebra. I hope it works well. And thank you for watching. See you later. Have a nice weekend. Oops.